class, this video is going to help with 6.2. And this section is going to be looking at our normal distributions, okay, normal distributions, and finding that probability using the idea of a normal distribution. So we have two, or like our key concept here is basically you can standardize something by converting it to a z-score. So we take our value, any data value, we subtract the mean, divide it by the standard deviation, and we've now standardized that point, that value. So that value would then become a z like you see on this one, and or we could have used an x like we see on our non-standardized. So we can have standardized or non-standardized. For us, StatCrunch will do either one, and it will convert it to a probability for you. So the step of converting it to a z-score actually isn't that important for us. So we don't really have to standardize everything to find our probability under our area under our curve. So let's look at these two things here. We have our non-standard normal distribution. And what that is it uses the mean and the x value that you're talking about. And it uses the standard deviation of your actual data. Okay. Over here, we have now standardized everything. So the mean is 0, standard deviation is 1, and we use the z-score, not x, but our z-score. And hopefully this helps you remember z. Anytime I'm looking for the probability or a z in our normal distributions, we're using the normal calculator in StatCrunch, which we'll use for our examples here in just a second. Okay, so the biggest takeaways are the shaded area is our probabilities. So we're still doing probabilities. We're just kind of saying, oh, well, if it's normally distributed, right, then I can get my probability of something kind of harder using technology or formulas. So let's look here. Example 1. What proportion of the men are taller than 72 inches, which is the height requirement for a shower head? So if you're taller than 72, you aren't going to fit. So the heights of men are normally distributed with a mean of 68.6 inches and a standard deviation of 2.8. Find the percent of men who are taller than a shower head at 72 inches. Okay, and I put on the note sheet that you can look at that's in your lecture section as well. This can be done in StatCrunch, Excel, or with tables. So sometimes it'll post a table for you. You could use that. That's the only way I learned back in the day. But now really you could plug it into technology and it'll give you the answer as well. Okay, so what we could do, let's just simplify what we have. We know our mean is 68.6. And we know our value that we're looking at is 72, and you want above. How many people are taller? Okay, and your standard deviation was 2.8. So we could do this using that data. So I am going to, you won't be able to see this, so maybe take a second, pause and write that down, because I got to open. The screen share here. All right, so here's StatCrunch. So what we're going to do is we want the probability of people taller than that 72. So I'm going to go to Stat, Calculator, and Normal. We have a normal distribution. So let's take a second and look at this again. We have our standard, and then we have our in-between. Which one do we need for this example? Are we between two numbers, or are we above or below one number? We're above 72 specifically, so we can do the standard. It always comes up with the 0 and 1. So if I had the z-score, I could plug that in now, but I didn't take the time to find my z-score. So the way that I could do this is I could change the mean in here to be 68.6. The standard deviation was 2.8. and we want greater than, and this is our x. You get out something below 1 because it's a probability. So it better be between 0 and 1 right here, always. So we put in our value of 72 here and then compute. They always say to sketch a graph so you can make sure you are getting the right answer in StatCrunch. It really does help because it shows like you're at 72 and above. I can see I did it right. I have the above portion. What was the probability of being in that? 0.11 or 11%. So again, I went to Stat Calculator Normal to get this normal calculator. All right, so let me okay, so we are going to say if we use these numbers here, then our probability of being above 72 is going to equal 0.11-ish. It was 11.3. Okay, I couldn't remember. All right, what would be another way to solve the exact same problem is to standardize it. So what I mean by that is I'm going to find the z-score. Well, the z-score is where you take your value, which was 72, subtract off 68.6, the mean, divide by the standard deviation, and if I calculate that out, I get 1.21. So this is my z-score. Okay, so 1.21. Then what I can do is I can go back into StatCrunch and in here I would have our 0 and our 1. We're standardizing it. Okay, and then you are greater than 1.21, and what do you get? Same answer. So we would have to standardize things and find the z-score for our value for a lot of formulas. In the olden days, should I say it that way? But for us, really, it doesn't matter which one. But you need to know that this would be a z. You're putting in a z here and getting out a probability when these are 0 and 1. Okay? You're not putting in x, you're putting in z when it's standardized. Okay. So now what we want to look at, just a couple things I want to point out. The graphs are super handy in StatCrunch, and I would sketch one so you know, okay, I'm at this 72 and I'm looking for above that 72. Otherwise, you might get the wrong section in there, and I just want to make sure you're getting the right thing. Don't confuse the z-scores and the area. Z-scores are distances along the horizontal scale, z-scores, but the area are the regions under the curve. So if you're asked for the area under the curve, it's the same as the probability. Okay, it's just that 0.11 or that area under that curve. So you're asked the probability, which is the area under the curve. Like those are the same thing there. Make sure you choose the correct left or right side. Okay, so I think we're good with that idea. Let's take and answer this next question. So let me share. All right, so we've talked about this one before, but when you're designing equipment, one common criteria is to use a design that accommodates 95% of the population. We have seen that only 46% of women satisfy the height requirement for the U.S. Air Force pilot. What would be a maximum acceptable height of a woman if the requirements were changed to allow the shortest 95% of women, okay, to be pilots? So basically, we want 95% of the women to be able to be a pilot. How should we design this equipment? What is that height of that person? So we need to find the 95th percentile of height of women. Okay, so the formula method, if you know Z, then you must convert, if you know Z, then you must convert to the equivalent X value. Use the conversion formula by entering the values of these, blah, 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 to solve. So you might have to use this to solve if you don't have X. So what we're going to do is we're going to go into our StatCrunch and we're going to find this out with our 95%. So think about your graph. What do you want your graph to look like if you want 95% of the women to be able to use your equipment? Then you would want 95 and below. Okay, so again, I'm going to go to Stat, Calculators, Normal, and I just pulled up a new one. And we want the 0 and the 1. And what we're going to come up with is we want this to be below 95%. So see how it's asking the question in a little different way? So we now have 95% of the people are below, are right there, are at a z-score of 1.644, right? Because it's a z-score. Why is it a z-score? Because you have 0 and 1. What if I want this to be an X value? Then I can put in that mean of, what was the mean of women? 63.7 and 2.9 for the standard deviation. And again, I want to put in 0.95 over here. And what's it going to find for me? My X. There's my height. So if I put it in the way I see it, I get a Z. If I put in the numbers, I get the X. So it just depends. I want the X. And there was that formula as well. Go back over here. Sorry, I have to bounce between the two, but it's the only way. So, so what we're going to write down for this is we used StatCrunch, and we put in that X is less than or equal to, this is going to be my answer, right, equals 0.95, and we put in our mean of 63.7, and we put in the standard deviation of 2.9, and that gave me my answer, which was I don't know if I wrote it down, 68.5. So basically, this formula is handy if StatCrunch didn't do it for you. Okay, so if I had to use a chart or something, I would use 0 and 1. I'd find my Z, and then I would have to times it by the standard deviation and add the mean in order to get back to 68.5. And I don't remember, our Z was like 1.645, I think. So we could put that in here and solve back to get this answer. But what way do I think is probably the best? So this is what's hard with a lot of what we're learning now. There's a lot of ways. I think if you use StatCrunch's normal calculator, you're good. You can also do normal distributions in Excel as well. And it's like the key is normal DIST. And the way that you would put in, like our example for the men, was it went 72, 68.6, 2.8, and you had to put in the word true. True was a little weird, and that's always under, always. So Excel will do it too, but it's always what's under that point. If you want above, you have to take 1 minus that answer to get your above section. So note that you can do it in Excel as well. Okay. So a woman must be 68.5 inches tall or below for us to meet the 95%. Okay. I have a couple more questions. And number 3 here, find the area under the curve of IQ scores of adults who are below a 92 with scores that are normally distributed with a mean of 100 and a standard deviation of 15. Let's just go bounce in to our stat crunch. And this one says below, so we want less than, and our mean was 100, which is the mean, about the mean of a IQ, standard deviation of 15. Oops. And we wanted how many people were below a 92, and that's our actual X value. Compute how many people are below a 92. Here we are. And we can see our solution will be 0.296. I don't think that's right. Okay, so I'm going to write that down real quick. So we can have our little curve, and we know that we're here at about 92, and you want less than, and this one will be 0.2969 is the probability. Okay, what if you were asked to find the area of the shaded region? So it's asked different. The area of the shaded region. So you could be asked the probability or the area of the shaded region of the graph below that depicts an IQ score. So you clearly can't see the graph below. Maybe I could do, no, I have an idea. Okay, here we go. So if we're asked the area of the shaded region, so here's the graph. How are we going to find this? And we have our 100 and our 15, and we have our really small number of 78. So we want to know how many people are above a 78. And that's pretty much saying like how many people have a pretty normal ability to think or have that IQ. So then we would go over here, and where's the 78 go? We have the 100, we have the 15. Where is the 78? It goes here. And was it above or below? It was above, and we compute. So 92.9% of people are above an IQ of 78. Okay, number 5 here. Find the area of the shaded region between two values. Yay, we haven't done this one yet. So if we want something between an 80 and a 130, so 80 to 130 is pretty normal. How many people are between those? Still have the same mean and standard deviation. I kind of just want to do a bunch with the same mean and standard deviation. So this one we have to click the between button. So when it's blank, it's what you're picked. I always think it's this one and click between them, but we have the 100, we have the 15. Now we need to change these to be between 80 and 130. Okay, and then compute with everything there. So our X values are between these. So you can see that it's the right section, and it says 88.6% of the people are going to have an IQ score between 80 and 130. So you can get the between pretty easy there. The last one says, what's the X value? So let me show you that one. Let me blow this up a little. So small. There we go. So find the IQ score of the graph to the right or below, whose scores are normally distributed with the mean of this and this. I am saying the area is 0.4. What was the X value? Area was 0.4. We get out the area or the probability here. So we're going to change this. We need to go back to standard. We need to change this to be 0.4, and we wanted greater, so we should be good. There we go. 103.8. I think this homework should be like 6-1. I think you should go pretty quick because you're using the Stat Crunch. Just know if I use a 0 and 1, it's a Z. It's a Z here, not an X, it's a Z. And just be careful of the between and the standard, and I think you'll be able to go pretty quick through this homework. At least I'm hopeful. All right.